Okay, our next test we're going to talk about is called the root test. This series, the summation of a sub n, converges absolutely when the limit as n goes to infinity of the nth root of the absolute value of a sub n is less than 1. That's the convergence for the root test. The series a sub n diverges when the limit as n goes to infinity of the nth root of the absolute value of a sub n is greater than 1, or if that limit is equal to infinity, which is, of course, greater than 1. Okay, the roots test is inconclusive when the limit as n goes to infinity of the nth root of the absolute value of a sub n equals 1. So it's the same rules, but instead of doing a ratio, a sub n plus 1 over a sub n, what we did for the ratio test, we're now doing a root, taking the nth root of a sub n. That's the only difference. The rules are the same. It converges absolutely when that limit is less than 1. It diverges when that limit is greater than 1. Inconclusive when that limit equals 1. This one works best if we have a series that involves some number raised to a nth power. Okay, let's look at a few examples. So for a here, we have the summation of n equals 1 to infinity of 2 to the n over n factorial. So we're going to take the nth root of 2 to the n over n squared, the absolute value of that. And so the limit as n goes to infinity of the nth root of 2 over n to the n squared. Now let's divide up that nth root to the numerator and the denominator. So we get the nth root of 2 to the n divided by the nth root of n squared. On the numerator, the nth root and the n power cancel each other out, and we're left with just 2 as our numerator, divided by the nth root of n quantity squared, because we can factor out that square. And so when we're working through this, we see that we can factor out the constant 2, and that series there goes to 1. So 2 times 1 gives us 2. So we get that this limit approaches 2, which is greater than 1. And so our series, this diverges by the root test. Okay, looking at example B, we have the summation of n equals 1 to infinity of 2 raised to the 3n plus 1 power divided by 2n to the n. So let's try the roots test. So we have the limit as n goes to infinity of the nth root of our a sub n term, the absolute value of the a sub n term. And then we can break up our nth root to the numerator and denominator. The denominator, the nth root, and the n power cancel each other out. So we have the nth root of 2 raised to the 3n plus 1 times the 1 over n power, because that's what nth root means, divided by n. If I do my distributive property to my exponent there, I get 2 raised to the 3 plus 1 over n power divided by n. And working through that limit, I see that that limit as n goes to infinity is equal to 0. Because n goes factorial, it's 0. We get 2 cubed. We get 8 over infinity. 8 over infinity is 0, which is less than 1. So our conclusion is that this series converges absolutely by the root test. Okay, looking at example C, we have the summation of n equals 1 to infinity of e to the 2n over n to the n power. So we're going to do our roots test. We got the limit as n goes to infinity of the nth root of our a sub n, of the absolute value of our a sub n term. And then we're going to break up that nth root to our numerator and denominator and simplify down. I'm going to just do this in a step. So we got e to the 2n raised to the 1 over n power, and then n divided by n as our denominator. And then simplifying that exponent, we get e squared over n. So we got a constant on top and a infinity on bottom. So that limit goes to 0, which is less than 1. And so by our root test, our conclusion is this series converges absolutely. All right, looking at our last example here, we have the summation. We're going to do our roots test. So again, the limit as n goes to infinity of the nth root of the absolute value of 1 over 1 plus n, quantity to the nth power. The nth and the nth root cancel each other out. So we're left with the limit as n goes to infinity of 1 over 1 plus n. And so that's 1 over infinity, which is 0. So 0 is less than 1. So this converges absolutely by the root test.